All right, everyone. Welcome back to another episode of Machine Learning Operations Coffee Sessions. Thanks for joining us. We are here with none other than Geoff Sims, who is the principal data scientist at Atlassian. You know, I've got my main man, Vishnu, here with us too. And Vishnu is in the eye of the tornado right now. He is and the blackout, the Verizon blackout that maybe some of you are experiencing at this very moment too. This will date when we record this video because some people who watch it will probably go back and see. But Geoff, on the other hand, is in sunny Australia. So, Geoff, thanks for joining us, man. I appreciate it.
Hey, no worries. Thanks for having me.
And we've got a lot of stuff that I want to get into. But I think it's probably right if we just start with your background because you've got some really cool stuff that you were doing. You were in Antarctica for a while, freezing your ass off, and you had a quite the journey to get to where you are right now. So can you fill us in on how that happened?
Yeah, for sure. So I guess, I started doing at university a Bachelor of Science just in physics, just a vanilla degree in physics with a flavor of astrophysics. I had some time off after that. Later on, decided I wanted to continue doing my astrophysics because I really loved it. So I went back and did a PhD for 4 years. And again, that was in Australia, but we partnered with universities in the USA and also China. And I was working on deploying instruments to Antarctica for the purpose of understanding potential astronomical observing sites there a little bit better. So I got to go down to Antarctica with the United States Antarctic program, which was, one of the best experiences of my life.
Mm.
And then after that, you're looking at all the exciting things you can do with astronomy and academia, and then kind of realize the grim reality of how difficult it is to find a job where you just get to do research for a living, as well as all the complications of having to pack up and move countries every 3 months or 3 years rather. And so that's when I kind of did the classic academic thing and go, oh, well, where else can I apply my kind of skills to data analysis and statistics and whatnot? And so that led me into machine learning or data science, I guess, more generally. So my first job was at a big data science analytics consulting company called Quantium in Australia. They do retail, or they do a lot of things, retail, banking, healthcare. But essentially, it's all machine learning and analytics driven consulting. So we worked for a big supermarket here, equivalent to Walmart or something in the US, essentially trying to predict what people were going to buy and then using that for pricing strategy and promotional strategy. And after a few years of that, it was just I saw a new opportunity in data science at Atlassian, Atlassian being a company I knew pretty well. And I've been at Atlassian for the last 5 years. So maybe we can leave it there and we can talk a bit more about what I do at Atlassian if you're interested.
Yeah, definitely.
I'm sure we'll get there.
Exactly. And this, for everyone who is tuning in, my idea of this was to go through a bit of a case study on what Atlassian's doing, how it's going, and then pick your brains about your learnings on what you've been up to since you got there and what you've seen over the years. I mean, you have this breadth of experience that you can share with us. And so I'd love to know how you've seen things change from those first moments when you started down this path, and then how you've watched it evolve, and what are some major things that you've seen change in the ecosystem during your time.
Yeah, so I guess there's a lot to unpack there. In terms of, I guess if we just talk specifically about Atlassian first, rather than the industry more generally. So when I started at Atlassian about 5 years ago, it was quite interesting because in a way, from a machine learning and data science or data maturity perspective, it was almost a big step backwards. And I say that not to criticize Atlassian, but if you think about it, a lot of the hype, or not so much hype, but a lot of the companies that are leading this space it's, your Facebooks, your Googles, LinkedIn,
Mm-hmm.
the list goes on, as well as all your smaller startups, right? They either have a business model that is built on machine learning and artificial intelligence, or they're some kind of like subscription service that critically depend on AI in order to succeed, like Netflix recommendations, Amazon, etc. Atlassian, on the other hand, essentially just sells products, and they didn't really need any machine learning. So I went into an organization that was kind of beginning that journey, so to speak, but definitely not set up as a mature data or machine learning organization. So from that perspective, it was a real big shock. Like for example, one of my first tasks was, can we run this? Can we run this snippet of SQL daily and like produce a report or something? Some kind of menial kind of task like that. I was like, sure. Like, can you just point me to the right person where I can run a cron job and just set that up somewhere? And they're like, oh no, we don't have a server where you can do that.
Huh?
It's like, okay. So I had to kind of, to cut a long story short, I had to go down this whole journey of learning how to deploy microservices, to deploy a microservice specifically to schedule jobs that started off as SQL and later on became machine learning. But it was like, we just don't have that set up. Therefore, I just have to go and talk to people and learn how to do that, kind of add that to the tool belt, then move on to the next task. So that was the kind of process, at least 5 years ago. Yeah.
Wow. Yeah. And that's something that we've been talking about quite a bit. And there's very, very opinionated people on whether or not a data scientist should know something like Kubernetes, for example.
Yeah.
And it seems like you had to figure that out by necessity. You needed to go through and say, okay, well, considering the maturity level that we're at right now, I guess I'm gonna figure out how to do it and create something of value. So good on you.
Yeah, that's exactly right. And I think a lot of it's just about expectation. And I think in this case, there was somewhat of an expectation on me, like from the team, that I would have these more generalized kind of adaptability and resourcefulness to do that. I think that's one of the things that thankfully you learn going through a PhD. A PhD is quite similar to that. Your supervisor, advisor isn't holding your hand for 4 years telling you what to do. They give you like a few gigabytes of data and they say, go, right? You have to work out things yourself. You get different data formats. You get weird snippets of code from archaic languages. You have to work out how to compile it. Like, that's just the nature of doing that, at least in my experience. And so it wasn't too different, but I think in general, it definitely, like as a newcomer to the field or something, you certainly need to understand the maturity of the organization as to what should be expected of you. And I think at least now you probably have a little bit more flexibility there, because machine learning and stuff it has been kind of mature for a few years now. That, like, it'd be hard to say, like, should a data scientist know that? Like, the answer is probably you don't need to. Like, it'll make you probably more employable if you have a diverse range of skills. I think these days people kind of just want to jump into a company and do the Kaggle thing. It's often not the case, but you've kind of got to work out. Like, there's a whole lot of different situations. You've got to kind of find your way through them and work out what's right for you, I guess.
And you said something really interesting about how there's those companies like the Facebooks and Netflix where their business model depends on machine learning. So they're all in on machine learning and they're figuring it out. And they say, like, we got to hire as many people as we need to. We got to get as much infrastructure as we need to make sure this works. But then there's those other companies that have been successful, and machine learning is something that, okay, cool, let's add it because we can, but it's not necessarily priority number one. How did that shape, like, when you were going about doing things? Because I think about MLOps, and a lot of times we talk about how MLOps is an organizational problem. And it's specifically in these companies where machine learning isn't priority number one that you have a lot of disconnect. Did you feel that too?
Yeah, so I guess, like, personally at Atlassian, when I started, I was kind of I was working within the support division, so I was just doing kind of my own thing end to end. I was handling almost the entire production line of machine learning there. So MLOps wasn't even really a consideration. But I guess more prudent to this conversation is the last few years, I've been working on the actual in-product ML at Atlassian. So features within the products that are powered by ML that, hundreds of thousands of customers use, like millions of people a day. And so with respect to that, that was certainly where I'd say this MLOps stuff was really, really relevant. And when a decision was made by the powers that be to kind of start thinking about, putting AI in our products or ML in our products, just to make them, the little things you do, just make them a little bit more pleasant. We had no systems in place, really, nothing, like no infrastructure. And so this was essentially a 2 to 3 year engineering effort to kind of build stuff from the ground up. And it's interesting because in a way, what we did achieve in those 2 to 3 years was pretty spectacular. Like there was a small amount of resource attached to it. So a few kind of 2 or 3, I think, like really, really experienced and really, really talented engineers and machine learning kind of engineers to build this kind of MLOps capability. But still, at the end of that, it almost wasn't sufficient. Like it just didn't scale, and it was just riddled with problems. So it's kind of like a criticism and a praise, really. Like on one hand, amazing achievement, but like realistically, it wasn't suitable for the growth and the kind of scale that we want.
Interesting. So there's a lot to go into there, and I want to get into all of it. And so maybe we should start, and for a little context, because you mentioned how when you joined Atlassian, it was almost like taking a step backwards.
Yeah.
So at the Walmart of Australia, were they more advanced? And so you had seen how it looks when it is advanced, or was that also a bit further behind?
Well, yeah. I mean, so at my consulting company called Quantium, so they were like an AI first, or they were an analytics first, I'd say, an analytics first consulting company. So they specialized in consulting when data and analytics and machine learning was required. And yeah, they were totally leading the way in terms of experimenting with new technologies and at-scale machine learning. They had in-house Hadoop clusters, which is something you don't really hear about anymore, but that was pretty cool. So like literally, shiny servers and stuff in the office, locked away in a cool room, which I think at the time was one of the biggest Hadoop clusters in Australia, like physical ones, like excluding Amazon and the like. So yeah, they were certainly more advanced with respect to that. And Atlassian, when I joined, it kind of just had a scattering of, I guess Atlassian called them data analysts, but in practice they were often kind of full stack data scientists. Like just a couple of people scattered around the org in different departments. So one person in customer support, one person in marketing, one person in like product analytics or something. So that's kind of how it started. And there was no real like product machine learning, so to speak. It was all like internal analytics, if that makes sense. So
Yep.
you're building models or doing analysis on in-house stuff, not for the purpose of improving a customer experience on the other end. There would have been a little bit of like experimentation and analyzing A/B tests, probably a bit of marketing stuff, but not really any in-product stuff. So the products weren't actually being improved using machine learning at all.
So there was,
or rather, we didn't have machine learning powered features in the products, I should say.
Yeah, exactly. That makes complete sense. So there were those random full stack data scientists that were scattered and doing their thing in the business.
Yeah.
And then you said it on your team or someone, you all decided, hey, we're going to need to do something to standardize or to create a procedure around this. And you set out on this 2 to 3 year journey, and ultimately realizing that 2 or 3 engineers for the scale that you have, I think, what did you just say? You said 1 million customers a day or a million?
So we have like hundreds of thousands of customers, which are like deployments of Atlassian on the cloud. And then, like I would have to look up the exact number, but millions of active users. Yeah. Monthly active users.
Which so
it's pretty big.
I'm totally going to go on a tangent right now. When you built that whole thing, I imagine you were using Jira to build the whole.
We manage all our projects internally using our own tools. Yeah, so Jira would have managed. I should say, just for the record, I kind of came in to that specific team like partway through that journey. But yeah, like all our own tools are used to help manage those projects. The actual tools and stuff itself were built in Java. Jira is more managing the kind of the running of the projects and whatnot.
Yeah, cool. I hear Vishnu has been resuscitated. Maybe he got a little internet back. You got a little juice, man.
It's always the way Zoom does confusing things, right? Yeah, I was talking to myself for the last 10 minutes, just reacting to all the great things Geoff is saying. Just flying off the wall, like, wow, that's awesome. But nobody can hear me.
We didn't hear any of it. Nope. Did you have a question for him, Vishnu?
Yeah. So you mentioned that there are these full stack sort of data analysts and you I think around the globe, I think I would be surprised if the vast majority of software development didn't happen on Jira, right? It's so pervasive. How would you say like the switch sort of flipped at Atlassian, where they were like, okay, now is the time to start investing in this more seriously and devote full-time resources to the question of infrastructure and scale around machine learning? How did that happen?
So I guess it came a little bit of a surprise, but way beyond my pay grade. I guess at some point the right person came in and kind of, it may have even started as an experiment. I'm not entirely sure. But it was like, to be honest, it was probably like, look, everyone's doing this. We should probably be doing it as well. And it was like, cool, let's hire a bunch of people and see what happens.
Oh, that is
wow. And so was that, it's interesting how things like that can happen. Somewhere it appears on a slide deck and then someone's like, okay, wait, we need to make this on a slide deck for real.
Sometimes if you say it enough times, it'll happen, right? If the right person says it enough times, you just kind of, it just becomes like fact. That just becomes a fact that that's the way it is. That's what's happening.
So did that come out of the engineering organization or the data org or the business org, like for the product? Where did that come from?
So that's a good point. What data org? It would have come out of the engineering org at that time. And I guess that's half the problem, to your point, that at that point in time, a few years ago, there was no real central data organization. I mean, in fact, that's something that's just happened recently, and we can touch on that more later. But it's kind of funny looking back, because like your perception of things, I find, is always adaptive, and it's easy to be in whatever situation you're in, kind of see the pitfalls and everything. But when you reflect, like you look back 2 or 3 years or 4 or 5 years and see the state of things back then and see how much more immature things were, that's when you kind of really get that sense of how much things have improved. So yeah, like the point was, there was not a data org. It was just an evolution, and it's hard to kind of, sometimes it's easy to be critical of things like that, but then given the state of things at the time, like maybe it didn't make sense to have a fully fledged data org of 50 or 100 people or whatever. So yeah, I think, to go back to your question, I think it came out of the engineering org because there wasn't any centralized data organization. Thankfully we had someone that cared enough to kickstart it, basically. And then it's like, once you've kickstarted it, you're an established team, and then you can only improve from there.
Yeah, no, that makes a lot of sense. It's funny how all these things tend to have a certain amount of sort of path dependence to them. And I think, for a company like Atlassian, where, the engineering is probably mature enough to be able to support multiple functionalities and let them grow and then split them off when it makes sense, yeah, I think you're right. It probably did make sense at the time, maybe not necessarily to have a pure data organization. And it's now it makes sense to, right? Because now you've reached a certain scale, you're doing,
I wanted to go into that
Go ahead,
a
Demetrius.
little bit on how the consolidation went from these full stack data scientists that were scattered around the company to now I imagine you're all working together, but as one data org and you're doing things and affecting or contributing to different parts of the business.
Right. So it kind of went down a little bit differently. So these kind of people scattered around that I spoke about, that kind of remained the case for quite some time. So the build-up of kind of specific machine learning capability kind of was independent from that. So that was kind of like a new team, and a lot of new staff actually came in from various places around the globe to kind of build that capability. And so even to this day, I don't think there's been like any kind of formal or informal merge. Rather, each of all those scattered people now have well-established teams that they work with, and the machine learning kind of team also is a much more well-established team.
Well, and then it begs the question of, okay, so there's these little teams that are working now, and it's very clear and they're more established. Did you, because I want to get into tooling, and you talked about these 2 to 3 engineers that they tried to build something and how that worked, and it was a blessing and a curse.
Yeah.
And maybe you can walk us through that a little bit more and how that played out.
Yeah, so I guess if we first start maybe with the problem that we have, so we're trying to build models to power something in the product that will be used millions of times a day. Now, that in itself isn't too bad, but when we think about when we have a product, how we derive features and things like that, or behavioral signals, typically in a cloud-based product, it's at least at the first stage driven by product events that get fired when you click buttons and do things, perform actions. Now, the type of scale that we're at, we're talking about billions of events per day that get streamed in. So we're in a kind of pretty big data realm. And then if we think we've got to build a model that will adapt to everyone's kind of behavior. And so let's take an example, like in Jira, if you need to assign someone a ticket, right? Like maybe we could have a predictive list for who you should assign to the ticket. And you want that to be dynamic. Like you don't want it to just be a batch thing that updates once a week or even once a day. You want it to reflect the type of work that you're doing, right? Because it's kind of synonymous with being agile. And if you change what projects you're working on or who you're working with, it should update relatively quickly. And when I say that, that's I think faster than a day, at least, is probably what you expect. A day seems too slow. And so then you're in this problem of, okay, we've got like some event stream of 2 billion events coming in a day, say, and you want to update features in close to real time. It doesn't have to be real time, but it needs to be, like I said, close to real time, probably faster than a day. Like that is a hell of a lot of data to process. And then not only do you need to process that data and convert that into some kind of like features that will feed a model, you need to have it then served back to the model at low latency. And so that's, I guess, your classic MLOps problem. So we're not in like a batch world where we produce a data set and just run a model over it, save the model artifact and something like that. Like we don't run batch features or batch predictions once a day. We're kind of in this world where we've got billions of events streaming in. We want them to update relatively frequently, let's say within minutes or even hours is still very difficult. And we want it to be served back immediately. And so that's the challenge that we were really posed with. Sorry, I can't actually remember the question, but that's at least the context to the problem and the size of the problem.
Yeah.
Which I don't think is particularly unique across any big like cloud product, but at least we'd never tackled that before.
Yeah. So then you went about tackling it, and how did that play out?
yeah, so we had some very smart people essentially right away to be able to convert those streams into real-time features. I probably will be a bit light on the technical details of exactly what they did, but essentially it was transforming events in real time to features, storing them in a Dynamo store, and then allowing those to be retrievable, and some kind of wrappers around that and APIs and things. So then once we had that, you could then have some kind of a model that used 10 features, let's say, and then it could just collect those 10 features from a Dynamo store, which is very, very fast, and use those features as input to the model. The biggest problem that we had there was that, cool, we've got this, like, let's assume the system scales well and everything, which it didn't, but let's assume for now that it did. We've got this nice online system. It can produce the features online and it can serve them to a model. The problem then is, like, how do you build a model? Like, how do you get training data? Because you can't just store all this data, like, because if you're storing everything, that is just the raw event stream. So you've essentially got to recreate this process of producing features in an offline environment in order to simulate what those features would be in production. And so then we're just in this total mess of, like, well, cool, a data scientist has to go and simulate this work based on a definition of a feature and hope that their definition is the same, and then build a model, then deploy that model, and then it's using features that are built in a totally different independent system. And, like, for the most part, you can argue that they're close enough or they match. But the point is that there's no guarantees, and you've got definitions everywhere. You've got no sources of truth, so it creates a lot of confusion.
Yeah, lots of room for error.
Exactly.
Wow, that is an intimidating scale problem, especially when you're talking about not having a source of truth, right? I'm sure you probably got turned around a lot in the process of, like, what is actually going on.
Yeah, I mean, it's very, very difficult. And it's funny because in some ways there was a source of truth, like the features that were produced online had code, but they were kind of like nested Java code, where you import this definition from this other file and that inherits from some other parent. If you've ever looked at Java source code and seen the nested folders, like, it's really difficult to kind of like work out what's going on. And that was our definition of features. And, like, that was suitable, like I said, ignoring the scale aspects, it was actually suitable for the online portion of the problem. It just wasn't suitable for the offline portion, because you couldn't use that to produce features for training a model. So then you have to say, all right, well, this feature's defined as blah, and it roughly means this. Therefore, write some SQL or PySpark or some other code to recreate your version of that feature independently, like for some previous point in time, and then use that as a feature to your model. Train your model, and then we'll switch out the inputs to the model with the online feature. And that's, yeah, that does create problems. And then, of course, when you talk about, I don't want to go a huge amount into, like, model interpretability and stuff like that, but even when people would ask us, oh, what exactly are the features you're using? And it was difficult because we didn't have, if someone said, oh, what features are in your models? And look, all of our models were simple. They were usually small logistic regressions with up to 10 features. It's like, there wasn't even, for a given model, there wasn't like some config YAML file that had the 10 features listed with some human readable name. It was actually not, it was actually a big task just to work out what 10 features were in there. So it was tricky, yeah, for sure. And, like, you'd have, for example, like the model artifact the data scientist created with their naming convention in there, but then, like, they're mapped to some completely different space and different terminology and different conventions. So yeah, it was just very, very confusing. But again, it's like that was the first time we'd done anything like that. The first time is always tricky. It's always hard to optimize when you've got one example.
How did?
Sorry, one quick question I have. Yeah, sorry.
Yeah, go for it.
How did you stay on the same page? right? I mean, I'm sure you guys probably had a lot of different resources from different kinds of professionals. You're talking about data scientists, you're talking about people writing in Java who are doing this online stuff, some data engineering. How did you guys stay on the same page across all those different people and professional types for this project?
I guess the short answer is we didn't really. It was hard. Like it was like a very like, again, not to be critical, it was just like a very messy project because we had entirely different goals. Like building the online system to do all this was just totally disconnected from the needs of like what a data scientist does or how they would even work with that. And so it was only after like a couple of years that became the next problem to solve. It's like, okay, we've got this system in place. It's a little bit clunky. How can we make it better? How can we align it to training models better? And those sorts of questions.
How did you feel like the priority of needs came when you were building out this whole system? What was the first thing? Like, what was the first bullet that was 6 inches away from your head? And then you said, okay, it wasn't after time that we realized we need to figure this part out, which was this feature problem. But was it the serving part that was hard in the beginning, or was there something else?
Yeah, I think it was just the scale of doing that. Processing like those huge event streams, having some logical rules to convert them into nice features like counts of how many times users have done particular things. And then being able to then have that immediately served back to you. I think that was like seen as the big engineering challenge. And it probably was the big engineering challenge. It's just the unfortunate side effect was that even when that was solved to the best of its ability, it had limited use and limited scale.
Yeah. So then how did it evolve? What did you guys do?
So I think it's like, so that was, building literally one model. And that's always the case. You invest, it's like, it took us 3 years to build one model. And it's like, of course, it did take 3 years to build a model. It took 3 years to build all the supporting infrastructure and everything you needed to run one model. And then it was like, cool. So we started building a couple more off that system. I think we went to 2 or 3, or maybe even 4 or 5. And, each subsequent one was a little bit shorter. So the next one might have been 6 months. And we kind of finessed it a little bit. But we kind of realized that there were just, like, I don't know how else to describe it other than just scale problems with processing events at scale. Like when you have a streaming situation, if the stream chokes, for example, or you can't keep up, like how do you catch up gracefully? And problems associated with that kind of thing, we started to notice were happening more and more. For example, you have to then have alerting in place. You have to have auto scale rules in place, and all these sorts of things, which are just 100% complex engineering problems, right? It's like a product scale problem with all the classic auto scale, but it's just affecting your data pipeline and your feature pipeline. And we would notice that our models start performing badly when any of these blips happen. And then sometimes we got caught up in situations where our stream was, like weeks late.
Oh, wow.
And we've got this like system choking, and it's almost like sometimes you can, like when you have a system, you can get in a situation where you actually don't know how to, because it's a streaming situation, like if you pull the plug, the whole thing's over and you have to start again. So you don't want to do that, but it can be very hard to just like fix something on the fly if it wasn't well set up for that in the first place. And so we can get to a situation where our streams are weeks or even months old, and it just kind of, then you're throwing more engineers to try and fix it. And I think it was probably at that point that we realized like this is getting unmanageable.
Yeah, I believe it. It sounds like a nightmare.
Yeah, absolute nightmare.
So
okay, yeah, go ahead, Demetrius.
no, I heard you. You take it.
You heard the determination in my voice. I think it's really helpful to hear about how difficult some of these things can be, even at a company that is, well renowned for being a really good engineering company like Atlassian, right? I read your guys' blog all the time. I read your blog all the time to tell people at my company, hey, maybe we should be doing things differently. And so it's really good. Thanks for this candor. Yeah. My question is, so you're gradually building up this muscle in your organization. You're deploying models more effectively, and you're going through all the troubles that are associated with it. Maybe I'm jumping ahead, Demetrius, but I kind of want to hear, where are you now? Where do you feel like, Atlassian is with respect to this sort of MLOps question compared to where you were before?
Sorry, just give me one tip.
Yeah, no worries. Classic Zoom challenge.
Yeah.
Demetrius, does that sound good?
It's not even 6 a.m. and I've still got the kids in my Zoom. Do you want to sit up? So sorry. So where we're at now. So I guess there's two aspects. One I won't really talk about briefly is just the organization structure, and it's worth pointing out that just recently, Atlassian has actually built this formal data organization, and just this will add a bit of flavor to the next parts we talk about, but our whole machine learning engineering arm, so the people that did run those systems we spoke about before, and the people that do run all the stuff now, build that infrastructure for everyone at Atlassian to use, they're now in a central org along with all the other data kind of related functions in the company, which is a huge step forward, because it's like a hat tip to say that, hey, we care about this. It's important to us. And it also means you've got that kind of we're in the data org, and the head of data can you've just got a bit more swing when it comes to making decisions and stuff like that. So from that perspective, just structurally, we're in a much, much better place. But I guess the stuff that you guys want to talk about is how do we solve the actual MLOps problems? So the short answer to that is, one of the managers of our engineering teams had somehow been investigating or had heard of companies who do feature stores and feature work, MLOps, as a service. And we investigated a few different ones. Specifically, they had heard of one called Tecton. And yeah, again, long story short, and we can get into the details, we now kind of moved over onto the Tecton platform. So Tecton they provide a fully-fledged feature platform and MLOps kind of service. And funnily enough, in essence, it was very, very similar to what we built ourselves, in terms of they're both backed by Dynamo. They're both processing streaming data. I mean, Tecton just did 100 other things that we didn't do. Their roadmap was way, 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 way ahead of us. And also they'd done it before at big companies. And so it was we just almost, obviously there was a transition phase and an experiment phase, but in essence, moving onto that platform was put us exactly where we'd hoped we'd be almost instantly. Notwithstanding the actual practicalities of moving systems over and things, which is difficult, but in essence, it just put us in a good place almost overnight.
So you were able to leapfrog with that, and shout out to the Tecton people. We've had them on the show a few times. So that is really cool to hear. I can imagine that when you were doing this, transitioning from yours to theirs, what were some surprises that came up, whether good or bad? What happened that you were oh, they do that this way? That's interesting.
Well, so I guess the not a surprise thing was that everything we'd kind of wanted or asked for, they got. It was incredible to just talk to a team, and that crew came over to Sydney for a few weeks to help us get onto it and stuff, and just talking to them, it was oh wow, they just totally the problem isn't foreign to them. It's foreign to everyone at our company, but there's oh yeah, they understood every
Empathy.
problem, and well, empathy, and also they had a solution to it because they'd done it before, and they had systems, like their system was built to handle most of that stuff. And so that was like the first really cool thing. The other surprise, I guess, I kind of alluded to was like, look, in essence, it actually was like very, very, very similar to what we built. It's some system that processes, well, I guess I should say Tecton can do a lot of things, but the part that we were initially concerned with, it processes a data stream, converts it into features, and stores it in Dynamo for retrieval. It was like, oh, architecturally, it's actually very, very similar. It was just way more mature. And, you know, they had all the other bells and whistles, like they had wrappers around it. It was like features as config rather than features as code. It was, they had a UI, they had logging, tracking, monitoring, auto scale logic, just a whole bunch of things like that were just nice to have for us.
Got it. That makes a lot of sense. I love that you said architecturally. That's one thing that we talked about this week in our newsletter, is this idea of how, you know, architecture enables capability, right? And it enables the capability to put models into production. It enables all kinds of things. And for example, the capability to make the right recommendation for a Jira task. And so when that snug fit happens between the service and your architecture, it is always nirvana. I'm curious, what has that unleashed you to do now? Now that you don't have to devote resources to maintaining this entire portion of your infrastructure, you're dealing with an outside vendor that helps you manage it and kind of has given you access to new elegant interfaces. What is it that, you know, that's unlocked you to do?
Yeah, so I'd say that the single biggest thing is independence from a data science perspective. So less reliance, less dependence on an army of engineers to kind of help you deploy features and models. So when I say deploy features, like remember in the old scheme, like let's say I run some SQL and produce a feature. I then have to like write a spec for that feature, get an engineer to re-implement that in optimized Java from first principles from a stream. Hope that matches what I did. And yeah, you can write test cases and stuff, but it's just like that whole process is just cumbersome. Whereas now, like I can find some historical examples of data. I can define some features in a centralized place in Tecton. I don't even have to write the code to join those features onto my historical data. Tecton actually does that for you. So one of the big things when you're creating training sets, like historical training sets to build models, if you've ever actually done the process before, it's a whole lot of joins, right? And you have to be very careful how you produce the features and join them on to make sure that you're not accidentally including time periods from the future in your features and things like that. And yeah, like that's solvable. It's just tricky. But the point is in Tecton, like let's say you define 100 features as snippets of code. You can just say, cool, join those 100 features onto this this labeled set of data. And it handles all the time travel and logic and join. It has knowledge of join keys. So it does all that for you. So in one click, you can join on all these historical examples and also then have faith or have confidence that any of those 100 features that you've defined can just essentially be one click put into production. You just change one parameter on those features that will start then serving them or producing them online, storing them in Dynamo and having them available for a real-time model to serve. That's all without any engineering input. So the data scientist is able to actually do a whole lot more than was previously possible, and to do that independently as well.
I just got to say, for the people that are not watching the video, you're missing out. I feel for you, man. I'm here with my daughters running around. Your little one is awesome there.
He's being very still.
Yeah, it's cool. He's making a cameo. So this is some great info that you're giving us on what and how it's evolved. And I'm wondering, what other pieces to the puzzle, like have you gone out and bought other tooling solutions, or are you just rolling your own around this central Tecton piece? And is it enough, like for the MLOps stack?
Yeah, so I think I'm not sure technically if it comes under MLOps, I assume it does. The feature side of things was our biggest pain point, and that's why we tackled it first. Far and away the biggest pain point. And I guess we're not at the stage where we've got hundreds and thousands of models. We've got a handful of models, you could count them. And so that's why we solved that first. I think the next thing, which is kind of the current problem, is more around that whole like model library, model serving, model versioning aspect. So you build a model, like at the moment, we're kind of in a transition phase, but like you build a model and then like manually host that somewhere and manually update something to serve that model instead of another one. So we don't have like like we're not using SageMaker, for example. We're not using any other kind of model serving functionality, but that's kind of our next phase to move into, because that's now, I always see it as like at any given time, there's a bottleneck of problem. Like, there's something that's a bottleneck.
Yeah.
And you look for where that bottleneck is, and then that's what you fix, and then you move on to the next thing. And that also speaks to the adaptiveness, because it always feels like there's a bottleneck of problems, right? There's something causing you grief, but if you look back a year, it's like, oh, at least we got rid of that one, which was way worse. And so at the moment, it's kind of around this, because we've solved all the feature stuff. Now data scientists and other people can work faster. So now it's getting to the point where, deploying models is now the slowest thing. Now that's slowing us down. So now that's kind of the next, one of the next big things to work on, like just that workflow around, once you've built a model, how do you automatically put that artifact somewhere for versioning purposes? And then how do you then serve that? How do you switch it off and on? How do you test it in an A/B test and that kind of thing? So there are various options there. Like I said, SageMaker is the classic one, but currently we're running our model predictions in-house. So we have services that can read serialized models and run them. I think at the scale we're talking about, like SageMaker would probably be too expensive, because in SageMaker you're making a payment each time you make a prediction.
Right.
And we make stupid amounts of predictions. So I'm not sure if that's the right approach. There are some other. I know that Databricks, we're pretty heavily invested in Databricks as well, I should say, just for the kind of all the stuff that goes around machine learning. So running jobs, experimenting with things, building models. And I know that they're kind of starting to put their fingers into the model serving space.
Yeah.
It's very experimental at the moment, but something we're looking at.
So basically, it's like you solve this feature part, your data scientists can build a lot more models a lot more easily. It's almost like their creativity has been unleashed, right?
Exactly.
Because they don't have to worry about, is this the feature that I've, you don't have to check all your boxes, so to speak, repeatedly. That makes a lot of sense. I'm curious, like so you said you're using Databricks. How is a model developed at Atlassian, right? So maybe, I don't know, a product person says, hey, I think, this would be a use case for machine learning. Go at it. I mean, could you maybe walk us through what that's like bringing a model into production right now?
Yeah, so I'd say we're still kind of working that out. So I'd say it is certainly fluid, but there's two ways. Either we have, like you say, a product team is interested in a feature, and then they kind of come to us and say, oh, cool, we're thinking about building a product feature that does blah, and to do it might use predictive power to, it might be a personalized recommendation, a personalized feed, or it could be like when you're on Google Drive and it shows you what recent documents you use, but it's a bit more than recent, like it's the ones you're likely to work on again. We might want to add stuff like that, because we're all about collaboration. And so we've had cases where they come to us and we kind of partner with them to do that. And then there are other cases where we kind of, I think, like data science and machine learning type people, often you see the opportunities as well, either because you've read a blog or you've seen it in another product, or you've watched a video or something like that. So we also have the reverse, where we kind of see use cases and then, try and get buy-in for interesting use cases. I would say that we're still kind of in the early stages of the journey. Like we're definitely not at the beginning, but we're not in this kind of rapid kind of model development phase. So it is still kind of a little bit ad hoc. But all these kind of MLOps type systems around us really enable us to do that, because it means when we undertake whatever the project is, it's like days or weeks to kind of go to a prototype rather than months or quarters, you know?
I think you made a lot of people very jealous by saying that right now. Well, that's something that we are continuously talking about. And we laugh, you know, how long it takes to get something into production and what is needed around that. So having that strong foundation makes complete sense. And also, I loved your quote about the bottlenecks, trying to find where's the biggest bottleneck and then just like getting rid of that so that you can move to the next bottleneck and then get rid of that. And then at some point, you're going to realize, whoa, like what I'm dealing with is a much bigger and robust solution. And the bottlenecks that I'm having are, you look back at like that first bottleneck and it's just, it pales in comparison to what you're dealing with.
Yeah, exactly. And I think a lot of people naively think the bottleneck is data scientists. Oh, we need more data scientists to build more models. Now that implies that at whatever these companies are, there's just, you know, a stack of training sets just ready to be churned through a model. And that's why people think, oh, you know, use AutoML, data robot, and just you build your models fast, just chuck all your data sets in there. And in practice, at least from my experience and conversations, that's just not the case.
Such a good point.
But rather like you have these other bottlenecks, and I think they kind of work nicely consecutively. Like, cool, you solve the feature problem. Now you solve the model serving thing. And as you move forward with each of those things, you're kind of approaching that place where, like, look, if data scientists and the need for AutoML was the bottleneck, that's a pretty good problem to have. But it's kind of moving toward that place. That's why I've always found it funny. I've never been hugely sold. I think the technology is great, and if you have a use for it, it's awesome, really impressive. They're just practically, I've never seen it as the issue that people have.
It implies that the problem is so clean and it's so identifiable.
Well, that too, yeah, that too. And I mean, like, even when a bit of diverging, but like even when these MLOps stuff are solved, right? We solve the features, solve the serving and everything. Like, let's say I have to build a new model. It's like, even that training set curation is not easy. Like, yeah, you can write the SQL in a few minutes, but it's not just that. It's like, oh, how do you sample it? How do you make sure it's representative? Like, there's so many things like embedded in that like, and all these other tools for building models automatically imply that step's already done. So yeah, I've always struggled with that. But like, I think conceptually it's kind of like you're walking toward that place, because that's the place you want to be. If that's your problem, that's good. That's when you're in the data science realm. Yeah, that's the promised land. That's where everyone wants to be. It's like, that's when you just hire a data scientist and you come in and you're just playing Kaggle all day, right? That's the dream.
Yeah, promised land. Take me to the promised land.
100%. Yeah, I completely agree with that. And I think, you know, the other challenge is it's also kind of defining what success looks like. And this is, you know, in terms of delivery, right? Software delivery. This is something that we've talked about a lot recently on the podcast, right? Like, what does it mean to deliver software, you know, effectively, efficiently, reliably, with maintainability, all those things. And then with that in mind, what does it take to deliver data related software, right? Data software that's a little bit more probabilistic, all those things. And, you know, I think Atlassian is an interesting company because so much of how software development happens is through your tool. It's literally through Jira and Confluence, right? And so from your standpoint, how do you think your evolution as a data org and your personal growth as a data scientist has happened because of sort of Atlassian's like sort of culture or approach to software development? How do you think that's influenced you? I hope that question makes sense.
Yeah, it's a tricky one. I think firstly, like using our own tools is like paramount, because we're our own customer as well. So we see and feel the pain, which helps us identify the problems and understand them. I think also just like in an analogous way that like we kind of spoke about different organizations growing independently, then needing to kind of unify. Like Atlassian products are almost like that as well. It's like, oh, you start off with a bunch, like 3 or 4 disparate products. Like you've got one that does code, one that does project management, one that does documentation. And like, obviously they link together and stuff, but like we're moving into like a true kind of unified product world where there's almost, you can think of it as just one product with different functionality. And then once you get into that, it's like, oh, okay, now you start to see all the need for how do you link products together? How do you navigate and find things that are relevant to you? And so being embedded, like using all those things for our own stuff every day, I think really helps think about the vision for how that would go together like long term. And that's some of like the exciting ML opportunities, I think. I'm not sure if that really answered specifically what you asked, but what rolled off the tongue.
Yeah. I'm not sure if I knew exactly what I was asking, but I like what I heard. No, that makes sense. I mean, definitely being the user of your product, it lets you come up with some ideas, and it helps you realize where things need to change and how that has to happen. I totally see how that can happen for your team and how that can be helpful.
Well, I want to say thank you, Geoff. I see you got the little one who's begging you to go outside and play. I know you're in summertime still, and it is morning in Australia. This has been absolutely incredible. I really appreciate you taking us down this journey of Atlassian and showing us what you've gone through and where you basically giving us your insights on where you can make the most impact, how you've done that. And I can't say thank you enough, man. This has been really useful.
This has been great. It's been cool to talk to you guys, and I'd be happy to do it again sometime to give you an update.
Yeah, for sure.
That would be awesome.
What the stack evolves into. I'm really anxious to hear how you continue to grow into this. I mean, you've got some killer problems, scale problems.
Yeah,
and so
for sure.
That like.
Yeah, I was going to say, like, probably it may make sense next time to speak with, one of our ML engineering type team, because they've kind of like solved my problems and we kind of work together on that. But now they're kind of like off on their own, solving the company's problems now and growing rapidly fast. So it's kind of moved from a joint problem to now I'm just a consumer of what they're doing. And so probably it may make sense to talk to them next time to hear a bit more of the details about what they're solving and can certainly help you out there with the right people.
Perfect. Well, I think that's it. That's all we got for today, Geoff.
Awesome.
Again, thank you.
Thanks a lot, Geoff.
Thank you so much.